In this video, we'll be looking at lesson 3.5, Algebra and Compositions of Functions. Algebra of Functions. If we are given two functions with a common domain, that's the input set, often we use X for our domain, we can perform operations on them. And this is going to, I suspect, be pretty straightforward for you. We'll end up treating functions much like we treat real numbers. Here are the facts. To say f plus g of x, to say f plus g of x, this is equal to the function f of x plus g of x. And we will define the other operations similarly. F minus g of x is equal to the function f minus the function g. F times g of x, you guessed it, it's f of x times g of x. I'm including that dot there just so it doesn't look so confusing. I could have connected them. Connected means multiplied. Lastly, just dropping down so it doesn't get too cluttered. F divided by g of x is equal to the function f divide the function g. And of course we'll have our ubiquitous can't divide by 0 statement. G of x here cannot be 0. We'll break math if we divide by 0. Alright, let's look at an example. Just one example. I'm going to use my multiplication rule here. I could easily have used any of these other ones. Let's say we have f. Let's define f of x. Let's define f of x to be the function x plus 2. And let's define g of x to be the function x minus 5. Okay, so the question is, what would f times g of x be? Well, it's going to be this one times this one. It's going to be f of x times g of x. This time I'm just going to connect them. Alright, well, what is f of x? F of x is x plus 2. In place of f of x, I have substituted x plus 2. What's g of x? It's x minus 5. Alright, so f times g is just like you would expect. It's just this one times this one. Alright, now I can do some multiplying. X times x is x squared. X times minus 5 is minus 5x. 2 times x is plus 2x. 2 times minus 5 is minus 10. Combining my like terms here yields minus 3x in the middle. Alright. And likewise, we could do all of these other operations. Okay. Compositions. Okay. We're going to introduce a new notation. And the notation looks like a little we're going to say f, and then put a little circle here. It's not a dot. Dot, that's this little dot we use to indicate multiplication, okay, or connecting. This is a small circle, much like the degree symbol, but they're in the middle, okay, perhaps smaller than I've written here. Okay, this notation here, this F circle G, you read it as read F compose G. We read this as F compose G of X. All right. What we're saying here, you notice that G is closer to my X. We're going to evaluate G of X, and then whatever comes out, we're going to then evaluate the F function at that. Notationally, we write it like this. It means F of G of X. All right. Notice we're taking our G function and we're inserting it into the F function. Let's look at a specific example. Right, let's say I have my F function and it is x plus 2. And I have my G function and it is x squared minus 5x. All right. I want to look at a couple of things. I want to know what is F of G of 3, and then B, I want to flip that. What is G of F of 3? And then I'm going to evaluate them for simply X. What is F of G of X? And lastly, D, what is G of F of X? All right, let's look at these first two side by side, A and B. Okay, draw a little line down. So I want to look at F of G of 3. This is saying evaluate G at 3, and then whatever comes out, we're going to evaluate F for that. Stated another way, F of G of 3 is equal to F compose G of 3 is equal to F of G of 3. So we're going to find G of 3, whatever comes out is going to go into F. Let's find G of 3 first. G of 3 is equal to taking 3 and substituting it into my G function. That is 3 quantity squared minus 5 times 3. All right. So this is 9 minus 15, that's negative 6. G of negative 3 is negative 6. Now I know that G of 3 is negative 6, so I'm just taking this negative 6 and substituting it in there. So now I want to find what is F of negative 6. Again, let's look at what I said. F of G of 3, F compose G of 3, is the same as F of G of 3. So I evaluated G of 3. It was negative 6. G of 3 was negative 6. So I'm simply taking this negative 6 and substituting it here where G of 3 is. G of 3 is that. So what I'm saying is F of negative 6. Well, F of negative 6, my F function is x plus 2. Simply substituting negative 6 in place of x. Negative 6 plus 2 is negative 4. So F of negative 6 is negative 4. Thus, this entire statement, we say F compose G of 3 is equal to negative 4. We've just taken 3 and put it in G. Whatever comes out, we put in F. All right, let's look now at the similar looking statement. G of F of 3. So this time, So let's look at the similar statement, G compose F of 3. So this time we are saying we're going to evaluate F of 3. We're doing this first, F of 3. We're going to evaluate F of 3. And whatever comes out of that, we're going to evaluate the G function. We're going to evaluate F of 3, and the output there becomes the input in the G function. So let me evaluate F of 3 first. F of 3 is going to equal, taking 3 and substituting in there for x. This is just 3 plus 2. So F of 3 is 5. F of 3 is 5. 5 is going right there. So now I'm going to evaluate G of 5. G of 5. Well, G is x squared minus 5x. So this becomes 5 squared minus 5 times 5. Lots of 5's there. I've simply taken 5 and substituting it in the G function. Every place that I see there is an x. Okay. 5 squared is 25. 5 times 5 is 25. This is 0. G of 5 equals 0. Thus, G compose F of 3 is 0. That is, if we evaluate F of 3, whatever comes out goes into G, the output will be 0. All right. Let's look at now C and D. Okay, C asks us to evaluate F compose G of X. So what that means is we are going to take G of X, that function G of X, and we're going to substitute it into F. We're going to substitute G of X directly into F. Well, let's start with what is F of X. F of X is X plus 2. Now, I'm going to take my function G and substitute it every place I see an X. Function G is X squared minus 5X. So, F of the G of X is coming in here. Again, G of X is X squared minus 5X. So, in here goes X squared minus 5X. Equals, instead of X, I'm going to use a parentheses to show my substitution. Instead of X, I'm putting the G function in here. X squared minus 5X. All right, let's key on the substitution. F of X is very simple. F of X is X plus 2. What are we substituting in place of X? What we're substituting is G of X, and G of X is X squared minus 5X. So you see, instead of X, I've put X squared minus 5X. Instead of X, I've substituted X squared minus 5X. This left side will stay the same. This right side, I don't need this parentheses. I can simply drop it. We have X squared minus 5X plus 2. These terms are all unlike, so I'm finished. I say F of X squared minus 5X is this. My initial statement was this one. F compose G of X is equal to X squared minus 5X plus 2. All right. So you can see that this is simply taking my G function and substituting in my F. Now we will now be able to go back up to this A statement and see this will work out. F of G of 3 should be -4. So let's take 3 and substitute it in here and see if we get -4. Well, 3 squared is 9. 5 times 3 is 15. 9 minus 15 is -6 plus 2 is -4. If I use this function and I substitute this value 3, it indeed outputs this same value that we got from our previous substitution. All right. D. G of F of X. So G compose f of x, we will take our f function, that's what we're evaluating first, f of x, and we will substitute it into function g. Alright, I'm going to start with my g statement. G of x is x squared minus 5x. Now, every place I see an x, I'm going to put my f function. So here I go. G, what is my f function? X plus 2. So x plus 2 goes here. Equals, instead of x, I'm substituting my f function, x plus 2. Quantity squared. Minus 5, instead of x, I'm substituting x plus 2. So every place there was an x, I substituted x plus 2 because that was f of x. That was my f function. All right. Equals, well, here we have this binomial squared. We need to write it twice. X plus 2 times x plus 2 minus 5 times x is 5x. 5 times 2 is 10. Okay. Multiplying this, x times x is x squared. X times 2 will be 2x. 2 times x, 2x. 2 times 2, 4. Still have this, minus 5x plus 10. Combining like terms, we have x squared is unlike. 2x and 2x is 4x, minus 5x is a minus 1x. And then 4 plus 10 is 14. This function here is g compose f. Skip down one line. G compose f of x is this statement. X squared minus x plus 14. Again, I will come up to this statement here, this one. G compose f of 3. We know G compose f of 3 is 0, so I should be able to take 3 and substitute it in here and it pair with 0. However, it does not. And that's disheartening, isn't it? It does not. I'm able to check this arithmetic now. When I substitute 3 in here, it doesn't pair with 0, and I notice I made a mistake here. Negative 5 times x is negative 5x. Negative 5 times plus 2 should be a minus 10 in this position. Forgive me. Minus 10. Minus 10. So, plus 4 minus 10 is minus 6. And here, minus 6. Now you can hopefully see how I was able to figure out my mistake. I need g compose f of 3 to go to 0. So this is my g compose f function. So when I substitute 3, it should pair with 0. 3 squared is 9. 9 minus 3 is 6, and 6 minus 6 is indeed 0. So here we evaluated g compose 3 and found it to be 0. Substituting 3 into this function, it maps with 0. Alright, with that you should be able to answer the questions from 3.5.